Raipur, and after that he has completed his PhD from IIT Kharagpur in supramolecular chemistry under the supervision of Professor Kumar Bidda. After completion of his PhD, he has got two doctoral fellowships, one from the Department of Chemistry, Georgetown University, USA, and second one from King Abdullah University. After that, Dr. Suman Samai has worked for various universities like Akal University, Talwandi, Punjab, Indus International University, Pune, Himachal Pradesh, and now presently he is posted as Assistant Professor of Chemistry at Department of Chemistry, Prabhat Kumar College, Hondai, Purbi Medinipur, West Bengal. The area of interest of Dr. Suman Samai are use of supramolecular materials, design of new gelator materials, synthesis of organic, inorganic hybrid materials. Some of the achievements of Dr. Suman Samai are world ranking in AD Scientific Index to 2022, and he was also awarded Best Poster Prize by RSC. He has published 9 research papers in reputed journals. He has presented his work in various symposiums, workshops, and on other platforms. Today, Dr. Suman Samai is going to deliver his lecture on supramolecular gels, the smart function materials. So, I would like to ask Dr. Suman Samai to take over the stage and start his lecture. Please, sir.
Thank you. Am I audible to all? Am I audible to all?
Yes, sir.
Okay. Thank you, Dr. Sharma, for your kind introduction. And first of all, actually, I'd like to present my big thanks to my friend Yunus, and obviously I'm grateful to my professor, who is the chief guest of this program, Professor K.K. Ghosh. Pranam to him. He is my guru, and obviously today all of my friends, all intellectual friends. So basically, today what speaking to a gathering in the Chhattisgarh, Chhattisgarh in such a kinds of things that I'm just going to my memory lane kind of things, that because in 2003 2005 actually I did my masters from Pandit Ravi Shankar Shukla University, and among the today's participant list I have seen one of my friends, Daharia is there, and obviously my colleagues is also going to join. So today what we are going to discuss, basically among you all the intellectual people. So definitely I'm not going to teach you, or I'm not going to teach you new things, but just I'm going to discuss what actually I have learned during these years, and obviously what I have learned in my IIT KGP days, and what I, I I have taken from Professor Weiss from my first postdoctoral guide, and my second postdoctoral guide is Professor Kasav. So let me open my. So is it my slide is visible to you?
Yes, it is
Okay.
visible.
Okay.
Yes, sir, it is visible.
Yeah, thanks. So, as mentioned by as mentioned by Dr. Sharma, that today's my topic is supramolecular gels, the smart functional materials. So, basically what we are going to do is that, so my topic is basically divided in four parts. First part is going to the very introductory remarks about the supramolecular chemistry, followed by three examples what we have done in our research life. So basically the examples what I have taken today for the lectures, so it is totally based on my uh, experiment and what we have published in different journals that was actually going to present to you. And obviously I'll be love to have some comments on you after the lecture. So what is supramolecular chemistry? So basically, I know that you are teaching the maybe some of you are teaching in the PG courses. So in our PG courses, we know there is one special courses in organic special, that is supramolecular chemistry. So I'm going to this very basic definition that what is the supramolecular chemistry? This is the chemistry of the intermolecular bond covering the structure and the function of the entities formed by the association of the two or more chemical species. As I have written over here, that molecular chemistry, which is dealing with the breaking and making of the covalent bonds, the supramolecular chemistry deals with the non-covalent bond. Okay, so molecular chemistry is involving with the covalent bond, and the supramolecular chemistry deals with the non-covalent bond. As it is seen over here, the two different kinds of molecules are coming together, inspired by the nature. So what kind of the nature actually we are going to discuss over here, and giving the functional materials, giving a association of the molecules. So what I have shown over here, that molecules with the supramolecular aggregations, it is giving the functional supramolecular materials. So it is something like a very common facts that for the chemist peoples like us who are giving their times in the lab for molecular synthesis. So usually we took a molecules and a precursor which is going to assemble together to form a cage-like of structures, which is kind of a very basic molecular chemistry. Maybe it is a cage, or maybe it is a linear type of molecules or something like that. But whenever we have the cage, so that time actually we are thinking that if that can be act as a host, and that host can be act as a to assemble or to hold some of the guest molecules, giving the supramolecular assemble something like this, which is shown over here. So it is not like that only particular guest, but if we put a guest molecules or library, that it is fitting that compromising of different size and shapes, but depending on the size and shapes of the host molecules, it is going to bind with a particular shapes and size of the molecules through non-covalent interactions and giving the host guest complex. This is nothing but the supramolecules. Now, it is said that actually when the topic first came into the existence, obviously uh, uh, I'm going to discuss about the very basics of history. It was said that this is a supramolecule is nothing but a kind of a super molecules, or we can say that the molecules or chemistry beyond the molecules, where the chemistry and the molecular chemistry ends, that supramolecule starts. So here we have seen one picture that with the different kinds of wheels, we are going to have a prospective molecules. And wheels is nothing but this pi interactions and all that. What are the different forces operating over here? That pi bonding, pi stacking, hydrogen bonding, solvophobic forces, electrostatic interaction, van der Waals interaction, and the metal coordinations. So what the examples what actually we are going to discuss over here today, that mostly based upon the these kinds of forces. And obviously I will be discussing much more on the hydrogen bonding and the electrostatic interaction and the metal coordinations. Okay, so now these are the concepts that already we know that Emily Fisher's that lock and key theory, where in 1894 that recognized, and even before the molecular structure was well understood, that shapes matters. And obviously the supramolecular chemistry totally deals upon the what type of different shapes actually we are dealing with these molecules. So in order for the two species to interact in a specific fashion, so they must have the complementary shapes and the chemical chemistry like the key fitting into the lock. Okay, so basically what we are going to do is over there that complementary functional groups should be there, and their shapes and the chemistry which is matching over there, that should be in complementary natures. Okay, so now for the lock and key theory and the indispute theory, that the very basic things I know that all of you know it's very well, that lock and key theory predict that exact kind of a guest molecules treating with the host which is having a complementary shapes. But the indispute theory is telling that that particular for to host a particular kind of a guest molecules, the host might not have the exact shape, but the surface side chains can move in a different way to exact host and guest complex, or maybe surface loose can move to hold the molecules tightly, or the domain as a whole it can move. Now, coming to my work precisely, that for a molecules which is taken over here in the solutions, so if we put the solution, obviously that solution should be a kind of a saturated solution. So if that we keep the saturated solution, why that what we are going to do, that just we have to keep the solution for a couple of hours or maybe a couple of days. So that time three things may happen from these solutions. What is that? The first one is that may some kinds of precipitation may appear, or if we are lucky enough, that some of the crystals may generate from these solutions. As we know, that crystals is nothing but the very orderly arrangements of the molecules, and whereas precipitate is totally disorderments of the molecules. But it is uh, not true to say that totally unordered, but it is some kinds of maximum unorderedness is there, and orderedness is very less. Now, in between these two effects, or in these two situations, if that happens, that time actually we get the gel. So gel is nothing but it is some kinds of some of the molecules or some of the group of molecules are arranging in a different fashion, and maybe some of the molecules, rest of the molecules is not. So in that case, actually we are going to have the gel. And here also the forces are the same what actually we have mentioned earlier. Now, so very firstly, actually we are only dealing with this mononuclear complex, dinuclear systems, trinuclear clusters. When this uh, concept is very much nascent to the peoples, that time actually we are just dealing with this kind of mononuclear complex. But now actually it has grown in a big fashion, and that molecular concept and molecular shape assembly complex actually going to a big way, and you can name any field which is ranging from the chemistry, biology, and the material science, that actually covering the supramolecular chemistry now. And the people who are dealing with the supramolecular chemistry are now thinking to 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 introduce all these subjects into the diverse field, ranging from the physics, chemistry, and the biology. And as far as the chemistry is concerned, we can think of different kind of applications right now, that ranging from the drug delivery, electrophoresis, gas separation, selective ion sensing, molecular recognition, molecular catalysis, molecular machines, and all that. And it is obviously it is not limited to the mentioned over here. Now, the best known supramolecular self-assembly in the nature is the DNA, all we know. And the DNA is double helix, and the nucleus, nuclear bases, which are bind together. It is nothing but the force of this hydrogen bonding. That we all know of that. Now, going to a brief history of this supramolecular chemistry. Actually, this host-based chemistry is the generation. It is the point where actually we can think of. So back in 1891, actually, whenever we are thinking of this cyclodextrin and the molecular cyclodextrins and the cyclodextrin structures and their different type of derivatives over there. So that time actually we know this is kind of a host-based chemistry. And after that, actually this Werner coordination theory came into existence, where the affinity attraction complexations actually came to the existence, and now this selectivity recognition come into the existence by Professor Emily Fisher. The biology people actually know it is better, and then Paul Eldridge. Actually, he is the person who coined the term like receptor, reaction, and the fixation. Receptor terms, which is very much important for this drug delivery system and the drug and the molecular association system inside our body. So first, the supermolecules terms was first introduced supramolecular terms first introduced by the Wolf, where the carboxylic acid dimers when actually they synthesize. So this is the very first examples where actually molecules are uh, coming together through the non-turbine interactions, forming just a dimer. Now, Linus-Pauling hydrogen bonding concept, which is a game changer concept in this regard. And after that, the P organization, recognition, templation, and this template synthesis comes into the existence when actually this works by the Pedersen, Jean-Marie Littin, and the DJ Cram, when actually they synthesized the crown ether and the cryptons. And we know that they got the Nobel Prize in 1987 for their works in supramolecular chemistry. And what they actually point over there, that supramolecular chemistry is the chemistry beyond the molecules, the science of non-covalent and intermolecular interactions in their Nobel uh, Prize notation. So just as there is a field of molecular chemistry based on the covalent bond, there is a field of supramolecular chemistry, the chemistry of molecular assemblies and on the intermolecular bonds. So we have to understand that as we have shown one pictures, that is a kind of a uh, football match or football game or maybe cricket game where actually each players contribute in a certain percentage and certain extent and that time and after that actually the uh, game came to the existence. So it is something like that. So what about the uh, forces actually we are talking about, this hydrogen bonding to coordination bonding and the bypass like interactions, sulfur interactions, they are actually involving very less amount of energy. But whenever this small less amount of energy actually coming together to form big molecules, that actually uh, play the game basically. Now, so already I shown. So after that, this molecular machinery came into the existence from the works from the James Fassi Student and the winner. And 2016 actually Nobel Prize, they have won these trial scientists, the surveys and the Student and Feringa. And I am lucky enough to listen the uh, lecture from Professor Ben Feringa and Professor Student. So for their design and the synthesis of the molecular machines, they won the Nobel Prize in 2016. Molecular machines. Now I am going to directly to my work. The very specific uh, field of this molecular association, there is the supramolecular gels, and obviously I will be talking about mostly the very small molecules. As we know, this kind of supramolecular aggregations can happen with a polymeric substance also, but my work is mainly based on the very small molecules. And already I have informed that or mentioned that the different kinds of uh, forces which are actually operating over here, that I'll try my level best so that actually I can cover all the forces what actually we have mentioned over here. Now, so what kind of things that we are trying to show here? This is nothing but the gelators. Gelator is nothing but the molecules which can form the gel with the help of maybe water, with the help of maybe some organic solvent or something like that. If the gel is formed in a water solvent or water as a solvent, we can term it as a hydrogel. And if that gel is formed in an organic solvent, we can term it as organogels. Okay, so this is some of kinds of gelator molecules which is present in the literature. So we can think and what different two types of things actually I have shown over here, that one type needs solvent and another type needs solvent and metals. So left side molecules need only solvent to form the gel, and the right side molecules need solvent and metals to form the gels. And sometimes actually we term it as a metal organic gel because the right side molecules need some of the organic molecules and the metal to form the gel. So that is why actually we are telling it a metal organic gel, or maybe sometimes it may take in the water also. Now, so my examples and our work is mainly based upon both of kind of things. So here actually I have taken only three examples of my of our work where actually we use the solvent and also we use the solvent and the metals. Both kind of things actually I will show over here. Okay. Now, so this is one kind of thing that we actually we are dealing with, that we can think of, that different kind of functional groups are needed to form the supramolecular association. So this is another kind of example present over the literature that we can have the molecular gel with the help of different type of solvent. Now, so coming to my first work, the two-component photoresponsive hydrogel, a sensitive platform for the humidity sensor. So first of all, I want to discuss about the hydrogel, the two-component photoresponsive hydrogel. As I have mentioned, the hydrogel is nothing but when actually we dissolve the molecules or dissolve our gelators in water and form the gels. So now this is the our molecules. So here this is azobenzene dicarboxyl sodium salt. When we this mix, when we this mix this molecules with 1:2 molecular molar ratio with CTAF like ethyl trimethylamine bromide. So within just 2-3 minutes we are having this gel. So at the very first point that in the nascent dye actually when we realize that gel is formed or not is nothing but just we just make this container of this containers of this total chemicals just upside down. So if that holds tight, that we can term as a gel. But obviously, we have to perform some of the uh, physical tests to assign or to assess that whether really it is a gel or not. So I'm coming over there. So this is the first molecule. So actually, where we are seeing this thing. Now, the beauty of this gel is that so only 33 milligrams of the compounds taking the both like 1:2 molecules of azobenzene and the CTF taking together at it 33 milligram of the compounds can immobilize 10 ml of the water in a test tube, something like this, and the percentage of this kind of thing is 0.33 weight percentage. And whenever actually gelator is able to make a gel in concentration below 1 weight percentage, then there is regarded as a super gelator. So our system acts as a super gelator as it takes only 0.33 weight percentage to make the gel. So there are very few examples in the literature where actually we can see that gel is forming with below 1 percentage or maybe below 0.5 percentage. So this is one of the very important examples. So now, as I have chosen the title that very smart materials, why actually they are very smart? Actually, this is nothing but that what are the different type of external stimuli that we can employ over here, and we can have some kinds of exciting results. So this is nothing but so if we put H plus or maybe if we just shake and rest, so that gel and the solid state can reverse to each other. And this kind of property like shake and resting property, we know that this is called the thixotropic property. And if we just put a H plus means acid, the gel breaks. And the beauty of these things, as that is why actually we have chosen the azobenzene thing, because we know that azobenzene N double bond N benzene ring, N double bond N ring systems can actually uh, acts as an UV and the visible reactors. So if we just put a visible light or UV light over there, so if we just put a UV in the range of 365 nanometers HU, so that gel is transformed to the sol, and again if the sol is again heat or exposed to the visible light, so again it is transformed to the gelatin state. And the same kind of sol and gel can be transformed or reversibly transformed through heat and cool also. Okay, so several types actually we can do it now. So not only that, so external stimuli like if we put the EDTA, that also actually we can see that the gel is breaking. So this is nothing but this is interfering the molecular associations. I'm coming over there. So now what are the different type of applications we are actually thinking of? So this is one kind of thing, that dye absorption property. So if we just put a crystal violet dye solution, so after the 84 hours we can see the changes over here. So definitely, and I have not seen over here that the UV visible spectrum of this crystal violet, because already we can see or we can realize through naked eye that what kind of changes over there. Now, so what are the proposal that what is happening over there? Because it is not the aim that uh, making the vial upside down and it is coming it is not coming down, so it is gel. No, the things actually start over there only. So our actually talk start from there. that okay, gel is formed, and what next? Actually, first of all, actually we have to think that after forming the gel, how actually is formed, because already we have mentioned earlier that whenever we have that kind of one kind of molecular associations and then one dimensional or two dimensional fibrous nature is there, and after that it is forming a entangled fibrous networks, and that actually responsible for the entrainment of the solvents whatever actually we are using over here. So the same things actually happening over there. So what is our proposal? So in the gel state, this in double bond in azo systems is residing over here, and the C tab is coming over here. And here actually we have these plus and minus electrostatic interactions, and these molecular associations comes over there. So the help of this pi pi stacking interactions. So our thing is that, and obviously here this CH2, 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 all that groups are there to have the van der Waals interactions also. So with the help of these kinds of small non-covalent interactions, it is forming one-dimensional chain, and this fibril network, then one-dimensional chain is ultimately going over a entanglement of the fibrous network, which is responsible for the total entrainment of the solvent, and here the water to hold. Now, this is the tame image of the hydrogel. We just put a very dilute gel under the microscope, tame microscope, and we have seen this kind of things are there. So this is kind of one of the things that matching over our ideas. Now, so what is happening if we just uh, irradiate these gel molecules under UV in 360 nanometers, and it is something like this. This, as we know, this is a very common chemistry that N double bond N in general actually it is uh, staying in the transform, and whenever it is irradiated in the UV light, it is transformed to the Cs, and this is something like this. That whenever in the gel state actually it is forming a uh, very order molecular association, and whenever it is forming a cis kind of thing, so it just orderness breaks, and ultimately the gel state also breaks. So this is kind of this variable temperature 1H NMR study, 1H proton study, proton NMR study. This is nothing but actually basically what actually we have seen, because when I have seen one slide that under heat and cooling also it is this gel and solid state also reversibly actually coming and going. So what actually happening over there? So our proposal is that whenever actually we heat this gel materials above 43 to above 45 degrees centigrade, the gel breaks down and the solid is appearing. So what is happening over there? So we have seen that in one NMR study that these protons are coming in a particular regions, and as the solution as the molecular association breaks, the totally different kinds of 1HNMR is there. Okay, so now already we know that 9 angstrom distance is there for the CC distance in the trans state, and for the cis one, this CC distance is 5.5 angstrom, and obviously the dipole moments and all that electronic nature also changes, and that is why our gel nature is also breaking down, as these molecules having a something like this kind of shapes, the D shapes. So it is very difficult for this ether to coming over here and also forming a particular nature of one-dimensional chains. So now, what already I have mentioned that what are the different applications or the nature actually we can explore with this kind of molecules. So this is one very exciting examples or exciting experiment that self-sustaining nature of these gels. So we have published this paper in the Soft Matter back in 2016.
Hello.
Yes.
Yeah, Dr. Suban, this is Dr. Pramod Goel from Kirodimal College, Raigad.
Yes.
So, can I ask one question?
Yeah, sure.
In your sol gel conversion in photo induced, can I see that slide? Actually, yeah, go. Next one. Here, this 360.
This one also you can see this.
Yeah. Thank you. At 365 nanometer, it is converted into solution form from gel state.
Yes.
So what was the temperature? Actually, during that UV treatment, you may get heat also. So how you can say that sol gel conversion is solely coming from your photo irradiation? It is not coming from heat. It may it may convert your gel state into salt during the temperature also, because your vials are showing few vapors in their vials, so it
Yes.
may come from heat also. So
Yeah.
I'm little bit curious about that. Yeah.
Okay. Okay. This is a nice question. Basically, yeah, for UV irradiations, as I have said, this sol gel temperature transformation coming over at least after 45 degrees centigrade. Okay, and this experiment actually I have in a total air condition setup, so something like 17 to 25 degrees centigrade. So from 25 degrees centigrade, a UV light cannot reach in a 45 degrees centigrade in a lab setup.
Yeah.
Okay, and also actually what instrument actually we are using over there. This is a sophisticated UV instrument that, and also yeah, actually I have checked in a just making a water vial also, just putting the gel in a water system. Like I took 100 ml of water in a beaker and I just put my gel over there, and also irradiate the UV light. That also that time also we see the cell gel transformations in 365 nanometers. Okay, and for
Okay.
the UV radiations, I don't know, but I'm really curious that from 20 or 25 degrees centigrade for the UV radiation, we can reach up to 45 degrees centigrade. I'm not sure.
Yes. Thank you. Actually, I was trying for 4+4 cycloaddition in anthracene, and
Okay,
yeah,
okay.
so a similar phenomena I observed during photo radiation. It was heating, and I was unable to get the result. So that is why I am
Okay.
little bit curious. So you,
Actually, for you, one excitement is there because today actually I'm going to soon see one things that 2+2 photocycle additions through
yeah,
UV. Okay,
yeah,
so
yeah. Okay, thank you.
I'm going to present
So
over here also.
yeah, so you have temperature controller in your setup, okay?
Yeah, yeah, yeah,
Right?
sure.
Yeah. Okay. Yeah. Thank you. Thank you.
Okay, thanks. Uh, okay, so this is self-fastening. What is going over there? That already we have proposed in our proposed model that electrostatic interaction over there, along with the pipe stacking and the van der Waals force of interactions. So what our study is that just we take a gel bar over there, cut in a two piece. This plus and minus and the electrostatic interaction total will be storing after the 24 hours. So your 30 to 30 hours. And obviously we have to make sure that solvent is right, because in this kind of actual I have the solvent should not dry. Otherwise actually we are not giving the all the gel bars in the same situations, because we are afraid that system is not closed. Definitely after 24 hours or after 36 hours, that some of the water vapors actually going over there. Now, so as I have told that for a gel materials, whether it is gel or not, we cannot just firmly tell by the seeing the upside down vial. So we have to going through this rheological behavior. So this is nothing but the rheological behavior is nothing but the mechanical property of the gel materials. So what kind of firmness or what kind of stiffness over there actually we can measure over there. So here actually two parameters is there. Like one is called G prime and one is the G double prime, which is nothing but the G prime is elastic or storage modulus and G prime is the viscous and the loss modulus. And this is G double prime. So this G prime, this G prime always higher than this G double prime actually indication of gel materials. And here with a particular angular frequency, we are giving a different type of strain over this molecule, over the gel molecules, over the gel materials, and we have seen that this G prime, which is up over here, so it is coming down over here. So this is a crossover point, which is nothing but known as yield. So yield stress is the point where gel mentioned that third mark just it will after and the images, and we can see that the third marks already disappear. And gel is also injectable because over this injection syringe, and we can we just collect it over here, and after a few hours, actually, this uh, as because the literature shows that hydrogel, which is following a kind of a electrostatic interactions and having some amines, so that can be used as a humidity sensor. So we are also thinking that okay, let's check whether actually we can use these materials for a humidity sensor or not. And yes, this is a collaborative work with the electrical engineering one guy metal jets. Now this is a very interesting one. So those who are interested in taking the 2 plus 2 cyclization reaction. So this is our molecule of interest, where actually we have put this NH, AN, this nitrogen, double bonds and all that. So there is a reason, because for this double bond actually we are going to see that 2 plus 2 cyclization reaction. So that is why actually put this double bond. And as actually we are dealing with the supramolecular aggregation, so definitely supramolecular aggregation needs the different complementary functional group, as already I have mentioned, the different complementary functional groups. So here the complementary functional groups, whatever actually we are putting over here, is that it's NH and nitrogen. So this nitrogen can act as a coordination site, this nitrogen as a hydrogen bond, and this nitrogen as a for a coordination bonds. So whenever we put silver nitrate in methanol, so we got a complex, but actually mm, it is far away that we are telling it a complex, because we just got a something like this, like a yellow kind of yellowish aggregations kind of things. And also this is not a strong gel as actually in the first example actually we have seen, because from this G prime and the G double prime data actually we can see that this is not a exactly straight line, or it is something like this, because G prime and G double prime the G prime minus G double prime actually mainly indicate that how strong it is or how firm it is. So here also we have seen that this here the difference is small and here the difference is big, and here also we have seen this ups and downs, and definitely here we can we get one yield stress value though, but this is not that G prime is top over here, but G prime is not a down kind of things. So that time actually we were thinking that maybe that gel is not that kind of strong. And also this same image is also showing that although we got the very nice 5 networks, but still we have some haziness. That time actually we are thinking maybe something is there. So what actually we did is that okay, as double promise is there, so let's check. So how actually what is happening if we just irradiate these gel materials through sunlight. So I did it. So irradiate under sunlight for 40 minutes and check by NMR. So I have not seen this NMR because I have the single crystal. So in the NMR actually, I observed that there is some kind of cyclobutane moieties are there. So after that, I separated the silver and all that. Then we saw that this is nothing but head-to-head dimer, and it is very unusual for for a kind of a unsymmetrical olefin, because this is an unsymmetrical olefin. This is bench imidazole over there. This is a pyridine over there. Okay, so definitely, so maybe this is not the exactly things that usually we can see. This is the head-to-head dimer. So, but basically, actually, we got the head to tail dimer, but here actually head to head. Now we saw that we are thinking that is there any way that we can see that any head to tail dimer? Okay, so this what actually we did that just after 5 hours. What is our observation is that this weak gelatinal nature or assembled nature actually giving one kind of precipitation, and after 7 days actually it is something like what actually is there, that one crystals is there. So we diffracted the crystals, and we have seen that this is a one-dimensional chains, and one-dimensional chains are coming together to to form aggregations, where actually we can see that the double bonds are coming in a parallel fashion. So each of these double bond in one-dimensional chains So it is exactly coming parallel to the next one-dimensional chains which is coming below that. And we have measured this distance, and this distance is something like 3.681 angstrom. Okay, and from the literature that time actually we have seen that for a literature for a 2+2 cyclodation effective cyclodation reactions, that olefinic double bond must be in the range of 3.5 to 4.2 angstrom. So after these observations, actually, what actually we did is that we just irradiated these crystals for 7 days, and the yellow powder actually got, and then separated the silvers and all that. And actually, here actually we are lucky enough to see the single crystals, and which is nothing but a head to tail dimer. So this is a very nice example, and as I have mentioned in the first one, where actually head to head dimer was formed, that this is the probable mode of aggregation in the gel state. Maybe this silver aggregation promoting these molecules in a head to tail or head to head fashion. Okay, so this is our conclusions that from a same starting materials from these gel materials. So whenever we are irradiating the gel itself, we are having this head-to-head dimers, and whenever we are waiting for like 7 days, it is converted into crystals, and after that, whenever we irradiated the crystals, we are going to get the head-to-head, head-to-tail. So this is a nice examples of regio and the stereoselective products from the same starting materials.
Hello.
Now,
Yeah. Hello.
yes,
Yeah. Sorry for again disturbing you.
sure.
So,
I was
have you calculated the ratio between head to tail and head to head dimer?
no, this is exclusive.
Okay.
This is
So initially it was head to head dimer,
yes,
and after keeping for 7 days, you have
yes,
observed
yeah.
head to tail. So there was
Okay.
any changes of that NMR peak or something in between of that?
No, no,
It is
no, no,
converted.
no, no. Actually, what actually I did is there. So just forming the gel immediately, I started the irradiation, and I checked the NMR, and it is exclusively this head to head.
Okay.
And conversion is very high. This is 95% conversion within just 40 minutes. I check the NMR in every 5 minutes, 5 minutes, 10 minutes, 40 minutes, 15 minutes, and we have checked this after 40 minutes. Actually, the things stops, and it is almost 95% conversion.
Yeah, head to head dimer is.
Yes, yes,
And
yes,
when you irradiated for 7 days, you have observed head to tail dimer.
yes,
Yes.
yes.
So higher energy is required, maybe. Yeah. Okay.
Yeah. So I waited for the 7 days, and the thing is that this gel actually gradually convert to the crystals, and it is really very unusual circumstances and unusual phenomena that that gel is forming to the crystals and entirely crystals. But yes, in literature, there examples are there when some of the molecules are converting to the crystals, but entirely convert to the crystals is very rare, and that is why actually we got the exclusive products, not a mixture.
Yeah, nice.
Thanks. Now I'm going to my last part of this talk. So it is already 15 minutes left. So this is chemical and the mechanoresponsive metal organic gels of this benzimidazole based ligands with the cadmium 2 and the copper 2 halide salt, self-sustainating gas and the dye absorptions. Now this is our molecule of interaction. Now you can see that in earlier examples we have this benzimidazole and the pyridine, and here also that time actually this double bond actually we need this asymmetry double bond. So that is why actually we put one benzimidazole and one pyridine moieties in two sides of the double bond. Now, actually, what actually we are thinking that okay, so if we take the symmetrical one, although this ligand is uh, really synthesized by other groups, but as actually we are going to see the self-assembled nature in the in presence of different type of metal salts. So we have chosen this one. Use of symmetrical and for this methanol and or maybe after not immediately, it is like 5 minutes. I guess it took. So after 5 minutes, we have seen this very firm gel actually it is formed. So literature shows that some type of these type of things also from this copper bromide gel, and that type of gel also showing some of the exciting properties. So after seeing that, okay, we are thinking that okay, let's explore what actually we can do over there. So this is the things. So with this copper bromide, we named this one as a MOG1 metal organic gel. So this work actually I have done in 10 years back in 2012. That time actually very little literature examples were there for this metal organic gel. Only very few. But now actually in India, actually a lot of groups are working in this direction. And for this copper chloride, we got also this kind of things with the MOG2. Actually, this zero point 0.1, 0.2, 0.3 up to 1.
Yes.
The this is nothing but this is nothing but equivalence of metal salt present with respect to the ligand in the each of the vial. And one thing is that total volume is 2 ml. So 1 ml with the copper bromide and on with 1 ml with the metal. Ligand. So I have dissolved this ligand in 1 ml methanol and dissolved this metal in 1 ml methanol, and then we put together, and after 50 minutes this is the result. So not only this copper, so if we put this cadmium bromide and cadmium chloride, that time also we have the same result. But the thing is that last time only start from this copper chloride, it starts from 0.3, and for this copper bromide it starts from 0.2 equivalent of metal salt. For this cadmium bromide, it is also starting from the 0.2, but this cadmium chloride from the 0.1 itself, it is forming the gel. It is very nice gel, and I am going to show you one thing. So this is the microscopic image of the only MOG1. This is the same. This is the optical microscopic image. This is the TAME. This is AFM images, and all that cases actually we have seen clearly seen that very nice uh, five-color system actually we can see over there. And this is nothing but this is one actually video is there, but it is PDF. So I'll show you the video at the last. So apart from this copper methanol, actually what are the different solvent actually we can use? So this is the different solvent actually we have tried, and we have seen that for this THF and this CH3NH2, this is all are actually transparent liquid precipitation, because actually this for this CH3NH2, this NH2 is taking part in the coordination with the metal salt. So that is why actually competition is there. So our ligand is just throwing out from the coordination site, and that is why no chelation over there. So not only for this copper sulfate also we can see one thing is that this MOG1, MOG2, MOG3, MOG4, that all that actually we have taken in all that case the halide salts, this copper chloride, copper bromide, cadmium chloride, cadmium bromide. But other actually anions actually not giving any gel, like nitrate, perchlorate, acetate, or tetrafluoroborate. Only the sulfate giving a very little or less amount of gelation behaviors. So that actually the reason over there, because this is a kind of a this halogen interactions or halogen breathing over there, we guess. So that is why the bigger anions are not working. So this is nothing but uh, different type of emoji, FECM image of the emoji 2 to emoji 5. And now this is again this rheology study, because without rheology actually we cannot claim that this is a gel really. So for this G1 and G prime and G double prime, we can see that this is a linear one, and G prime also linear. This is a very characteristic features of any gel. For G1 should be very G1 should be above the G prime, and it should be a parallel fashion. So in a particular in a frequency, not a particular frequency, in a frequency range. So with a fixed frequency, the different CS crest we are applying, and that time actually you can see that this is a sigma, we call it a yield stress, where actually gel state transforms to the sol one. Now this is a one table, very important things are there, because whenever actually we published this paper in 2012 in chemistry of materials, that times no examples were there in for the MOG metal organic gels, which is having a very high value of G prime and G double prime, because G prime and G double prime exactly that denotes that how firm and how beautiful and how uh, uh, mechanically strong the gel was. So this the difference the more is the difference, more is the firm the gel. So this G prime and G double prime, we can see the difference is this Pascal, and it is really a firm gel. And this firmness actually can also be used in a different way. So this one actually I'm not going to discuss. Only 5 to 10 minutes is there. So this is nothing but if we took the EDTA in the copper bromide gel. So if we add this EDTA, so we after a few days we can see these things happen. That some blue precipitation is there and a transparent liquid. So this is nothing but actually what we are thinking that this copper EDTA complex was separated. So this is a copper EDTA complex and this is a copper bromide solution. So again our ligand solution, and if we again put the copper bromide in the ligand solution, again gel is formed. So we are lucky, nothing but this EDTA is coordinating with our ligand. So that is why gel is gone. And this type of EDTA additions does not have any effect on the emoji 3 and emoji 4 because this is a cadmium one. So actually EDTA cannot ligand from the cadmium place. Now, so this is our proposed self-aggregation model where actually we have seen that this eggs, when this chlorine and bromine, we are having this hydrogen OH bonding. So that also actually we have checked in the NMR. I have not shown over here that in different concentration we have seen this OH is hydrogen bonding is coming in a region. So now this kind of emojis are showing excellent dye absorption properties. So this is a zero gel. Zero gel is nothing but if we just put this gel, that copper bromide or cadmium bromide or copper bromide gel in a desiccator, dry desiccator, and after 1 month, whatever is left at the bottom, this is called zero gel. So this is nothing but the ligand and the metal complex and some kind of association over there. Only there would be no solvent. So we just put the copper bromide zero gel over the dye solution, and after 24 hours we can see this is the solution we got. And we have checked the dye absorption capacity, and we can see this is the dye solution. So after 24 hours, this emoji can absorb almost 80% of the dye in a 24 hours matter. So we have checked all one. This is a rectangular shape. So the rectangular shapes can be divided into two pieces, and in the gel materials. So even the self-sustainability nature, actually we have seen this from this emoji 3. This is a very excellent outcome of our research. That first time actually we have measured like 1.3 or 4 centimeter height cylindrical gel, and we put 5 rupee coin, each having a weight of 9 gram. So after putting 20 such kinds of coins, and we have seen this actually left. So after putting this 1, 2, 3, so this happens. So after putting 20, this happens. So the things is not breaking down, or exactly it is not disappearing over there. After putting 20, 5 rupee coin, it is almost 180 gram. So this is from there actually we also say that this material is very firm. So what we have discussed today. So supramolecular chemistry and the non-covalent interaction. So two components smart hydrogel is supragelators and as its humidity sensor. And the starting from the same materials, regio and the stereoselective 2+2 photochemical reaction, and a multi-stimuli responsive self-sustaining metallogels and its various applications. So in acknowledgement, I'm very much thankful to my PhD supervisor, Professor Kumar Birata. He is now a professor in Department of Chemistry, IIT Kharagpur, and my first postdoctorate, Professor Richard Weiss, Department of Chemistry, Georgetown University, Washington DC, USA, and my second postdoctorate, Professor Nibin Kasab. He is now professor, not associate professor. He is now professor of Chemical Science Division, Physical Science and Engineering Division, King Abdullah University of Science and Technology, KSA. And obviously, I'm thankful to all the coordinators and the conveners, co-conveners, and all the organizing members, organizing committee, and definitely the principals of these two colleges. I'm very much thankful to Yunus, my friend, for this invitation, and obviously thank you all for your kind questions and giving me this opportunity to share my views. Thank you. So I guess I'm
Thank you
exactly
very much.
time. I guess I'm
Suman sir,
perfectly on time, Yunus.
Yeah.
Thank you, sir.
Exact one.
Thank you so much,
It was
Dr. Suman sir.
presentation.
So, I, on behalf of the organizing committee of this faculty development program, heartily thank Dr. Suman Samai for this wonderful presentation and sharing his knowledge in the field of supramolecular gel. He enlightened us on the topics like supramolecular chemistry and non-covalent bonding, its introduction, two-component smart hydrogel, a supragelator as humidity sensor. Besides this, he also shared his expertise on the topics like the history of supramolecular chemistry, various stimuli responsible for the hydrogel, dye absorption, properties, and rheological behavior of the material. We are thankful to you, Dr. Suman Samai, for this wonderful presentation. Thank you so much, sir.
Thank you very much. Thank you.
Good afternoon, Ambade sir.
Thank you. Is Ambade sir
हाँ यूनुस
present?
अभी मैं क्या लेफ्ट कर लूँ?
हाँ हाँ
Yeah, Suman.
हेलो सुमन
Ambade sir, how are you?
Yeah,
Sir.
yeah, fine.
sir
Fine.
sir good afternoon.
I'm good. Yeah, good afternoon. Suman,
कैसे हैं
Samai,
सर
thank
आप?
you.
Yunus,
बढ़िया,
I am
बढ़िया.
leaving now.
Yeah yes
Okay, thank you.
You can
Thank you
stay.
very much.
Suman,
हाँ.
you can stay.
Okay, Ambade sir. I'm actually today morning. Actually, I was talking with Yunus, and I was telling that okay, Ambade sir will be presenting, so definitely I should present over there. So definitely, I at least I will be present. What is the time now? This is 1 p.m. So
Thank you.
Yeah.
definitely after at least 10 to 15 minutes, I'll be there. Okay, Ambade
Yes,
sir, start.
Okay.
Okay, so over to there to Yunus. Thanks.
Good afternoon sir.
Good afternoon, bhai.
How are you
How
sir?
are you? Yeah, I'm fine. Yeah.
It's great honor for me sir to share same platform with you. You are the alumni of this department. I heartily welcome you sir.
Thank you.
Thank you very much sir for accepting my proposal to deliver a lecture on this platform. I would like to invite Dr. Ashwani Kumar Sharma sir to introduce Dr. Balram Ambade sir. Over to you, Sharma sir.
Thank you so much, sir. So, good afternoon and welcome everyone. Today, we have the privilege to have Dr. Balram Ambade among us to present his lecture on the topic atmospheric chemistry. I, on the behalf of Department of Chemistry, Digvijay Autonomous PG College and Department of Chemistry, New Arts, Commerce and Science College, Parner, Ahmednagar, heartily welcome Dr. Balram Ambade sir to this session of the 7-day faculty development program on chemical sciences. Let me share the brief introduction of Dr. Ambade. Before sharing the introduction, I would like to share that Dr. Balram Ambade is an alumni of Department of Chemistry, Government Digvijay PG Autonomous College, Rajnandgaon, and we are very proud of this, that the alumni of this department are working in such an important and prestigious institute of our country. So Dr. Balram Ambade is presently working as professor and head at Department of Chemistry, National Institute of Technology, Jamshedpur, Jharkhand. Dr. Ambade has completed his MSc from Government Digvijay PG Autonomous College Rajnandgaon, and did his PhD from Pandit Ravi Shankar Shukla University, Raipur, on the topic analytical studies of precipitates, rain and fog, and rooftop water pollution. He also did his postdoctoral research from the Department of Earth and Environmental Science, IISER, Bhopal. Since 2012, I may be, I must be specific. Since April 2012, he is working at Department of Chemistry, NIT, Jamshedpur. Dr. Ambade is a member of International Association of Hydrological Science and International Association of Engineers. Since now, Dr. Ambade has written 4 books and 4 book chapters. He also has 58 research papers in his credit, and he also presented 8 research papers in various national and international seminars and workshops. Professor Ambade has guided 26 MSc students, 11 MTech students, and 5 PhD students to complete their respective degrees. Presently, 8 students are working under his guidance and supervision to write their PhD thesis. He is also an editor of various journals like Elementa Science of Atmosphere, and guest editor at Chemical Pollution in Water, Air, and Soil. And he is also a guest editor at Urban Air Quality and its interaction with health, climate, COVID-19, and other socio-economic features. Till now, he has completed 4 major research projects funded by some reputed agencies of our country. Presently, he is working on 2 2 major research projects, out of which one is international project. So today, Dr. Balram Ambade will deliver his lecture on atmospheric chemistry. So I humbly request Dr. Ambade to take over the session and start his lecture. Please, sir.
Yeah, thank you very much, Professor Ashwani Kumar Sharma ji.
Welcome, sir.
Yeah. Let me share my slides, PPT, then I will have to start. Yeah, my PPT is visible to you.
Yes, sir. It is
Yes.
visible.
Yes, sir.
Yeah, it's completely visible or partially visible. Okay.
Please.
Okay, thank you very much for calling me for this wonderful FDP program conducted by Government Digvijay Autonomous PG College, Rajnandgaon, with collaboration with Department of Chemistry, New Arts, Commerce, Science College, Partner Ahmednagar, Maharashtra, Yeah, today's topic is atmospheric chemistry. First, sir has introduced of mine, so thank you very much. So let me start my work. Before that, I was very thankful to our Digvijay College. Yeah, when I was in my PG periods, I am just remembering those days from 2002 to 2004. I was the student of this prestigious institute, Government Digvijay College. So you can just see this was the building of my Government Digvijay College when I was studying PG there. I have completed my graduation BSc degree from Government Science College, Rajnandgaon only. After that, I went just I admitted on Government Digvijay College for my PG program. So this is wonderful memory in my life. I always and always uh, uh, realize those things. Olden days are we have already seen that the olden days are the golden days. So these are the these are my professors when I was admitted on PG. So that time Professor Tiwari Sahab and Dr. Kashyap Sahab, Anil Kashyap Sahab was the professor who taught me chemistry during those periods. So from those dates, he motivated me. I enjoyed a lot in Digvijay College. So from my journey of my 2 days is goes to Government Digvijay College, and I highly appreciate the success, and I always wishes a good wishes for the incoming students and outgoing students of this Government Digvijay College, Rajnandgaon. So so just before starting my presentation, I must tributes and thankful to my professors when I was in the Government Digvijay College. So these were the professors who taught me chemistry during my PG periods. So this first picture is Tiwari Sahab, and his name is Professor S.K. Tiwari. So he was the HOD during those periods, and this picture is our Professor Anil Kashyap Sahab, and he taught inorganic chemistry to us. This is Madam A. Kashyap, and this is Mishra Sahab. And that time, the principal, we were very lucky that the principal on that time was Mohbe Madam, Hemlata Mohbe Madam, and he taught us the spectroscopy and instrumentation parts. So we are highly thankful to our faculty members, and who taught me and who encouraged me during those periods to choose chemistry as a career or journey of my life. So I highly thankful to all the professors. So let's remembering to those days in my wonderful days spent in Government Digvijay College. I will have to just move to my lectures. Yeah, we have just seen that the chemistry is mainly divided into different. For PG students, we are telling you the chemistry is only divided into 4 types, just like organic chemistry, inorganic chemistry, analytical chemistry, and physical chemistry. So everybody were thinking that these were the only chemistical part, but now if you just go to the beyond this, and there are the many specific and many orientations and many complexities on chemistries were seen, and we have to just think that there is that many types of chemistries are happening on day by day. So my topic of research on 2 days is because is is the hydrological and atmospheric chemistry. So let one by one we have to just study the atmospheric chemistry. Let we can start from the atmospheric chemistry, then we have to move towards the hydrological chemistry, then we have to just move the current research which will have there is the gap. Let's many things were there in my presentations. So we have to just think about our atmospheres. In our atmospheres, we have to just think about our atmospheres. So why we have to just study our atmospheres? Okay. So why? Because in atmosphere there are the large number of gas. There is the blankets of different type of gas were present in the atmospheres, and these atmospheres are consist. We are in breathing. We are just using oxygens, and we have seen that there are the many oxidation reactions. Oxidation reactions are there are the many reactions which are present in the presence of oxygens. So we have to just see how these oxygens are behave and how this oxygen will be decide the parameters of the incoming reactions. So we have to also see about the nitrogen. Nitrogen is essential part of protein and DNA, and this is also very essential because in essential there is a protein, there is the large structures, and in DNA also there is the helical structures of pyridine and pyridines, and the adenine, guanine, and thymine. Many things where they are inside. It will just go depend of this DNA. And we have to just think about the CO2 is essential for photosynthesis because CO2 and water in the presence of sunlight, there is the photosynthesis process is there, and plant preparing their own food, and there is the water vapors and precipitations. You know the water vapors, the vapors and precipitation in the form of fog and haze or rains like that. So shall we just think about to protect our authorities? Just like we have to just see that nowadays the temperature of global means the world, even in the India, temperature is increases too much. So what may be the reason of that? So we have to just think over that how the ultraviolet radiations coming from the sun, and now it is there is the ozone hole concept is there, and which is very essential for us. We have to just also study some points over that, and we have to just think that the absorb of heat and regulates the temperature, allowing earth to habitate. And all because of that the climate and circulations of gases and particles over there, and these gases and particles are just attracting or attaching or hitting with the help of sunlight. So what is the photochemical reactions which we have to see? So there are the wonderful reactions we have to see. We have to just see very fine about the circulation of hot and cold air regulated by different climate zones, and we have to also there are the many species which are just around us, just like flora and fauna, which they are having a certain specific climate and conditioning zone, so we can survive or not, or what will happen on the earth if this type of global warming will be continue. So there are the many questions in our minds. So we have to just discuss one by one, and I hope in the end of this lecture you all will get a good knowledge of the environment and the atmospheric chemistry. So just we have to just think the earth atmospheres. Earth atmosphere, you can just think that after this this is the part of our earth, and above this, suppose I am sitting here, and above this what there are the different type of layers. So different type of layers are there, are air are surrounded with me. So what we can do? So just we have to see the permanent gases surrounded with us, that is nitrogen, oxygen, and argon. The variable gases, just like greenhouse gases, reactive gases species, and this you can just say that greenhouse gases is very important. There are the six type of important type of greenhouse gases which are responsible up to 11 kilometer. That is the troposphere regions. You can just see this is the troposphere regions, and above this region is the stratospheres. This region is called as stratospheres. So the distance of the stratosphere may be from 11 kilometer to 50 kilometers. You can just see. So this is the distance, and Here in troposphere, the major gases is just like nitrogen, oxygens, and carbon dioxides, argon, neon, and other gases which are here only. So now, just like you can just see above this, there is the stratosphere region. Stratosphere regions, this total region is covered with the ozone. And nowadays there is the problem of ozone hole. Because hole means there is this region is surrounded with the ozone or filled with the ozones, and the sun rays is coming, and there is the depletion of this ozone, and because of that the it become hole, and the ultraviolet rays come from the sun is directly reaching to the earth. So these were the reactions we find. After that stratosphere, there is the mesosphere, and mesosphere is also, you can just see the stratosphere and mesosphere, then thermosphere, and many more exosphere regions are there. So simply you can just see the temperature inversion. Temperature inversion is very important because the meteorological conditions are always very important in all the aspect of atmospheric chemistry. So you can just see, if you can just move from just tropospheres. Suppose you are here in ground, and you can just see, if you can just go to the suppose hill, this hill. So you can just see the temperature is become down or low. So when you will just see or go in upper sides or tropospheres, you can find the temperature is getting down. So from 15 to minus 60 around temperature. See, after minus 60, around minus 60, it will be temperature will be again gets increases. So there is the increased temperature after 11 kilometer height. So that layer is called as stratospheres, and after stratosphere you can just see here the up to 50 kilometer to 85 around kilometers. So again temperature is gets down. So you can then after the thermosphere you can again find the temperature after this thermosphere is getting high. So there is that temperature down, up, temperature down, up. You can just see alternate decrease and increase of temperature will takes place in this atmospheric atmosphere. So you can just see, suppose some gas is formed. Suppose we are just setting some industry here, or we are doing some vehicles. We are using industries for many productions. So these are releasing very harmful. They will collide with each other or not collide with each other. There are the many things or many concepts is there by which you can just say this is very important and very interesting chemistry. So you can just see there is the role of atmospheric chemistry in today's life. You can just see everywhere there is the gas. So people were mainly just only seeing the metals. People were just only seeing the other gases, but they are just not seeing towards the gas. So we have to just see one by one these gases. One by one, we have to just see that these gases. Suppose these are our plants, and these plants are just releasing certain quantity of biogenic volatile organic carbons. And these biogenic volatile carbons, as well as you can just see through there are the many dusting there is the CH4 Mars gases. It is called as Mars gases, which we are also gives us a different quantity of the methanes, and there is the burning which gives the different quantities are nitrous oxides, methane, volatile organic carbons, like that. The many things were it's are given, and these are released, and these are just going towards the upper and upper atmospheres. So there is the diffusion processes there. Diffusion processes there. Here you can just see in this particular line, you can just see that suppose these gases are just going upsides, and there are the many are in the presence of some others, just like condensation or precipitations. The reactions of this particular gases were disturbed and forming are inside particles, and this dust particle consists of CO2. So this will be just settle on the ground, or it will be just move for 1 month, 2 month. I don't know. All will be just move, but there are the then argon, then carbon dioxides, and there are the many more gases which are also equally important. Just like the radon, the xenon, the uh, the many gases, just like NOx. Okay, these are called as trace gases. Trace gases, just like NOx or SOx. Many gases were there in our atmospheres. So these gases are responsible for there are many chemical reactions on the atmospheres. So our main study is to just study the both natural process and human activities process. So that is called natural process, and human activity process, that is anthropogenic process. So natural and these anthropogenic activities are the major source of the formation of variable gases or the contamination of variable gases. So the burning of coal, burning of fossil fuels, burning of the fuels, and many just like volcanoes and other is responsible for to make the air polluted. So that is called as natural process. So we have to just see there are the neon, helium, methane, krypton, nitrous oxide, hydrogen, xenon, ozone. So these are the gas which are present on the lower part of atmospheres, or we have to say this lower part is called as tropospheric gases. So these are the gases which are present on the tropospheres. Okay, so these are the volumes by percentage are given. So let me just think for the different type of gases, that is called as a greenhouse and other gases. Before that, we have to just think that there are the source, sink, and atmospheric residence and time. So source, sometimes we have to see that source are mainly two types. First type of source is called as a point source. First type of source is called as a point source. Suppose this is one industries, and these industries are releasing the smoke, and these smokes are just coming on the troposphere zone. So this is called as a point source of gases. Okay, non-point source means what? Non-point source means the gases are coming from any source, but we have to just see the non-point source. Here we don't say this is coming from the industries, or which are coming from the vehicles, or which are coming from the burning of fossil fuels, or which are coming from the mining sites, or agroforestry, or burning of paddy, or burning of crops. You have already seen that nowadays in Delhi there is it is also called as gas chamber during winter periods. In winter periods, there are the gases combines were very huge in contaminations by different type of particles. Just like it is decided by CPCB, Central Control Pollution Board. It has decided by the NAQQS, National Ambient Air Quality Standards, as well as the BIS marks, the Bureau of Indian Standards. There is the many marks are there which are not following the gases. So there is the US EPA has also protected, given the different parameters by which the suppose the some criteria is not filling by the all type of gases. Suppose this suppose the nitrogen, oxygen, hydrogens, all these gases are just determined with the help of sampler. So in our lab we are having one sampler by which we are just taking the samples, and we are just measuring the different type of gases, just like CO2 gases, methane, nitrous oxides, ozone, water vapors. Like that, these gases we can easily capture with the help of a small portable sampler, and that is called as aromatic air sampler. Okay, so the different type of gases are present. Suppose that this CO2 is present, and all these are called as greenhouse gases because these are responsible for the global warming. So it is increase on the energy budget by the absorbing of some outgoing terrestrial radiations. You can just see, suppose these gases are some gases are coming. So these gases are just depositing on the troposphere area. Suppose the troposphere height is 11 kilometer, and you can just see from 6 to 11 kilometers, these gases are going upwards, and they are just making the layers of the atmospheres. Suppose the layers of atmospheres, and suppose the sun is coming, so and it will be just goes to here, to directly earth, to directly earth, and sun is one source of energy, and this gas is also radiating some heat. So from here also we are getting some heat. So you can just see sun is a source of energy. Sun is source of energy, or sun is giving heat to us. Similarly, these gases are also depositing on the surface, and they are just trapping with the IR radiations, and they are just making the layers of atmospheres. So these layers of atmospheres are making the
I think there is
हेलो सर.
सर की ओर से नेटवर्क में कुछ प्रॉब्लम लगती है शायद.
हाँ, हेलो.
आवाज आ रही है मेरी वोकल से?
आपकी आवाज़ आ रही है, लेकिन सर की आवाज़ नहीं आ रही है. एक मिनट.
सर डिस्कनेक्ट हो गए लगते हैं शायद. सर तो कनेक्टेड है. हेलो सर, आवाज आ रही है मेरी?
that can increase of the production of food, which also increases, and the consequences of greenhouse effect we have already seen. So this is a very beautiful picture by which we have to just see that
Sir,
this is the world.
एक्सक्यूज मी सर.
Yeah,
सर स्लाइड शो नहीं हो रही है, प्लीज शेयर कर दीजिए उसको.
slide show नहीं हो रहा है.
जी सर.
Oh, slide is not showing.
यस सर.
1 minute. Oh. अभी हो रही है?
यस सर. नाउ इट इज विजिबल सर.
Okay, ना?
ओके, थैंक यू सर.
Yeah, yeah. Please tell me if there is any problem, technical issue is there. So
ओके सर. यस, थैंक्स.
let me solve it quickly. Okay, you just yeah. So this is the very beautiful pictures of black carbons, because black carbons are responsible for the heating of atmospheres. So this is the black carbon emissions. So you can just see this is the world picture by which how much quantity of black carbons were present, and oh, the source of black carbons is different. So you can just see the US. This is the part of US, and here you can just see the black carbon emission is very less. Similarly, in America, North in the Southern America or Brazil or Canada, this part also you can just see the black carbon emissions is also you can just see this one is the line is just like yellow. Similarly, you can just see in China the diesel emissions are very important and very huge. So the to control and protect these digital emissions on their country. So similarly, in here also you can just see in India nowadays there is the green revolutions as well as the industrial revolution is there, by which we are just burning lots of quantity of fuels uh, and other fossil fuel burning, and the vehicles, and many developments are going on. Because of that, India, we are also suffering some domestic coal burning, and the different type of fuels burnings over here. So we can just see that in our country, this particular reason, because this particular reason means the reasons are Eastern India. You can just see the India is also other part of India is very less, but the Eastern India, you can just see this particular part, just to see. This is the part of a zone of Western India, and in which the large quantity of burning of fossil fuels were present here. So you can just see, I am just living on Jamshedpur. From here, there are the lots of industries is there. Means more than 1,000 of industries are located near to me. So these industries and other industries elongated with each other, and they are just giving a very dangerous situations. So we have to just see the changes of atmospheric concentration of greenhouse gases in different gases. Here, suppose the carbon dioxide gas is there. So carbon dioxide gases, you can just see how this increases in nowadays. In 1750, the greenhouse gases is 278 ppm V, and in 2011 it is increases, and 2022 we are just doing one research on that. So that is approximate, the values is coming approximate 420 ppm V. So like that, this is continuously increasing in and in methane gases is also, you can just see 72 ppm V, but nowadays it is 1.8 ppm V. So similarly, that the all gases in the dangerous gases, these are the dangerous gases, and the global warming responsible gases, which is increasing in our Earth. You can just see chlorofluorocarbon 11, chlorofluorocarbon 12. So earlier in 1750, the concentration was very negligible or equivalent to 0. But nowadays it is having some certain values. You can just see 0.24 in chlorofluorocarbon 11, that is parts per million by volume. Okay, so the parts per billion by volumes. Like that, this is increasing too much. So we are just working on that. So we have to just see one by one carbon dioxides. So carbon dioxide, we are capturing the carbon dioxide through one sampler, that is air samplers, AIEP, air samplers by aerometric aero samplers we are having in our labs, and we are just capturing this that there are different volcanoes or other things any happens. So suppose natural resources were happen, just like forest fires or volcanoes, or eruption, evaporation from oceans, or decomposition of organic matters. So here in organic matters, we are just polycyclic aromatic hydrocarbons. Polycyclic aromatic hydrocarbons, we are just concentrating on naphthalene. We are just concentrating on anthracene. We are concentrating on benzoypyrens. These are called, there are the 16 polycyclic aromatic hydrocarbons which are just given priority to by the US EPA, and which are say that these are the priority uh, pH, and which should be very carcinogenic, which is very carcinogenic, mutagenic, and very rare, and that should be controlled. So natural sources we are just capturing. Second is the anthropogenic sources. There are the many industries, and there by which they are using different type of fossil fuels, just like some is using coal, petrol, or diesel based fossil fuel burnings. So we are just taking the samples from these particular locations, and there are the deforestation and biomass burning, there is the agriculture burning, there is the paddy burning, there is the crop burning, there is the you can just see there is the pesticide usings, and many more things were there in anthropogenic sources. And manufacture of cements, manufacture of sponge irons, and many things were there. And we are collecting the samples from these particular locations. We are sending our students, PhD students, to collect the samples from these particular locations. And we have just see that there are the many things were also covered. So the more important things is that this is the very rare pictures. This is the very rare pictures, and these were collected, and this I'll tell about the billions of tons of carbon dioxide which are just emitting, and how the carbon dioxide is balancing our circulations over here. So fossil fuel burning contributes this much. Then land use, how much land use, then photosynthesis, then plant respirations, the decay of residues, and there is the uptake and intake of the oceans. You can say that there is the gas exchange between the ocean sides. Suppose some biological pumping is there, biological process there is the evaporation process there because of the presence of sunlight. So there is the salt sprays there. So salt is become just moving towards the above the atmospheres, and this salt will be just combined with the dust coming from the this terrestrial zone. So both will be just mixed, and they are just giving a different type of a very beautiful chemical reactions. And this are there is the photochemical reactions. There are the just we have already seen the photochemical reaction. Norris 1 type, Norris 2 type. So there are the many things and many stage of very beautifully chemical reactions we are studying. Secondary chemical reactions, primary chemical reactions, like that. So this was the very specific measurements, and this is published on Nature. And here you can just see the atmospheric carbon dioxide, and you can just see the atmospheric carbon dioxide is continuously increasing. So we are taking from 1960 to, you can just see here you can just see 2006. Our data is up to 2006. Even those that we are working, but the authenticate of data still has not done. So we are not pending. We are not giving data up to 2010. Okay, so you can just see in 1960 to 2006 how the carbon dioxide is increasing in our natures. And it is, I think that this type, suppose this carbon dioxide will increase too much in our nature or in our environment, so it will be gives a horrible impact on coming days, horrible global warming, you can say. So we have already seen that the global warming is increases day by day. The temperature of Earth is increases, or the Earth is getting warmer. So this should be controlled. We have to just see the carbon dioxide percentage is too much, and this that is having a huge gap. And there is also see, you can also see there is the this is the Hawaii studies. And similarly, we are performing for some studies for India also, and by which we are just collecting the satellite data, by which the India how and the ground data as well as satellite data, and predicting that in coming days in India's how this atmosphere or pollutants will be work. So there is the very fantastic and very wonderful results we are getting. You are just see. Suppose this is the suppose this is monthly variation is also there. Monthly variation. Just suppose you can just see January, then April, then July, then October, then January, like that. So you can just see the concentration of the pollutants or CO2 is very high during this month, and concentration is very low in this month. So you may be telling the results. I will tell at the end. So why the CO2 levels increases in spring and reduce in autumn? Yeah. Next is the Antarctica. You know, there is the Antarctica and Atlantica. These are the two just North Pole and South Poles, and which this total covered with ice caps. And nowadays, ice when the Earth's temperature increases, so this will be the temperature will be just fallen down. And here you just to see sometimes it will be increases. So there that is depend upon the monthly variation, you can say. Sometimes spatial variation and monthly variation, or monthly spatial as well as the seasonal variation. These are the two things by which we have to cover whole pollutant studies. So next study is about the methane, by which there is the primary natural source. In primary natural source, we have to say that what is the source of methane in our Earth. So you can say the natural source, that is oxygen deficient, and there is the process of wetland and rice paddy land, which are you can just say total concentration of 40% from this paddy fields. We are getting the methanes. Other source, natural source, you can just see there is the animal digestive process or cow dung, by which we are just taking the methanes out. Methane is also very useful for us for the getting of the fuel. It is working as a fuel for producing, but in the quantities of methane is very high, and if you cannot use the methane, so it is also very dangerous. So you can just see the animal digestive process. The cow can produce up to 200 liter a day. Then there is the forest fire, termites. So many natural sources also there. We can also see about the natural source or the anthropogenic source. Here in the anthropogenic source is the fossil fuel burning and the biomass burning, the disposal of the reuse and refuse of the landfill sites, etc. So here there are the many things where they are in zinc also. We can oxidize the CO2 and H2O, and there is the very large chemical reactions in the presence of sunlight, that is called as photochemical reactions in tropospheres, by which the methane is also very become dangerous, and which is also responsible for to hitting the earth atmospheres. So the fossil fuel combustions, and there are the many types of anthropogenic activity and primary source by which these gases are coming out, and these are reacting. Suppose why we are just studying these gases. Suppose these gases are formation of these gases is there. Suppose we are just capturing these gases, and we will just see how these gases will be just move. Suppose this will be gases will be move here. Suppose this will gases will be move here, and these gases, how these gases will be behave. So the petrochemical reactions and how these gases will be stay for a longer periods in the atmospheres. That is a very complex systems. So we are studying those complex systems, and the major thing that is chlorofluorocarbon, that is called as CFC. So here in CFC, two are very important, CFC 11 and 12. So CFC 11 and 12 are very important. So we have to just see what are the basic background of this the emissions of chlorofluorocarbon, that is it is used in coolant or refrigerators. We are using the ACs and other air propellants and the propellants from aerosol. Reena Sahu,
Rima Sahu.
Dr. D.K. Verma,
D.K.
Sri
Verma
Vikas
sir is-
Kande,
D.K. Verma
Sri
sir is here.
yeah, Sri, yeah, Gokul Nisad and Dr. A.S. Sharma. So these are where the faculty members and
Yes.
head
Gokul sir.
Yunus Raja Beg.
Yes, sir.
So
Verma sir is
thankful
Verma
to
sir
all.
is here with me and saying you pranam.
Yeah, yeah. Thank you so much. Thank you so much.
with me. Sir, Gokul sir is also.
Yeah, Sakuntala. Yeah.
नमस्कार सर, नमस्कार सर.
यस सर, हमारे सर मैं भी हूँ. हाय.
Yes. I know.
Thank you, sir. Thank you very much.
Yeah. Thank you so much.
Thank you.
I have presented
once again.
I have presented actually presentation to you, and when you will call me, then I will present more. And offline, I will just tell you, and I will teach you other things to the students too.
Yes, sir.
I am,
Definitely. Department is yours, sir. Definitely visit.
Yes. Of course.
Bobby ma'am is with us. Ma'am.
The students will get instruction from you, sir. You have
Madam,
inspired Ashirwad, sir. Blessings.
Yes,
Thank you.
प्रणाम मैडम.
Thank you.
मैडम कैसी हैं आप?
बढ़िया. Nice.
मैडम बहुत अच्छा लगा मैडम. थैंक यू सो मच मैडम.
बहुत अच्छा लगा सर. बहुत ही अच्छा था सर. बहुत informative. And we should give solutions also for to check this pollution.
Yeah. We are
Environment.
working. We are working on that particular only, madam.
Yes,
In
sir.
India, we are lacking many results, but nowadays many sophisticated instruments are with us. So our students are also working very wonderful
On this side.
that regards. Yeah.
सुनना.
Students are working on plants but not on chemicals.
पीडीएफ बना दे सब.
Yes, madam.
Pollutants.
Yeah,
Then it
madam,
will-
that's clear. Green chemistry concept is also there, madam, nowadays.
Yes, sir. Yes. बहुत अच्छा लगा सर. आइए राजनांदगांव.
जी मैडम आएंगे, बिल्कुल आएंगे.
It is your place. You are graduated. You are
बस आपकी कृपा थी मैडम वहाँ पर हम.
हाँ, बहुत बढ़िया सर. You have worked very hard for getting this position. है ना? That is the inspiration for students. Thank you, sir. Thank you. God bless.
सर आप हमारे डिपार्टमेंट की शान है सर. Thank you, sir.
Thank you so much.
बहुत अच्छा लगा सर.
I would like to request Dr. Sharma sir.
एक मिनट भी यानी ऐसा नहीं लगा कि कहीं बोर हो रहा है. वेरी नाइस. वेरी lucid. Very lucid way. Thank you.
Thank you so much, madam.
Atmospheric chemistry, it is a burning problem of today. बहुत बढ़िया.
Thank you so much.
सर छत्तीसगढ़ में सर बहुत गर्मी पड़ रही सर अभी.
इसीलिए तो बोल रहा है, इसीलिए तो प्रेरित कर रहा है, मोटिवेट कर रहा है.
Plantation, more plantation is needed.
कोल माइंस की वजह से और पर्यावरण को पूरा खत्म करने का इरादा है इनका.
कई सालों बाद बहुत अच्छा लगा.
जी मैडम. Thank you so much, madam. Thank you so much.
Sharma sir, over to you.
Yes, sir. Thank you, sir. Anyone from participants want to ask any question? Anyone having any question related to this talk?
Air atmospheric pollution.
Yes, ma'am. Thank you, ma'am. Pranam, ma'am. Okay, I think there is no question. So thank you so much, Amade sir, for this
Thank you.
wonderful and informative talk.
Thank you so much.
We are very thankful to you for sharing your knowledge in this important field that is important for everyone, for every creature on this planet. Okay, so you shared your knowledge regarding the how environment is important to us, and there are how many layers of atmosphere, how every layer is important to us, what type of changes are going on in these layers and in the composition of the atmosphere. Where you also shared the information about various gases like carbon dioxide, methane, ozone, and most of how to tackle the problem of problem related to the changes in the composition, and also the pollution. We hope that have physically we will have physically among us you very soon, and we looking forward to hear you physically. You uh, may present your expertise, your research work to the students of Government Digvijay College, Rajnandgaon. Thank you so much, sir, for sharing not only your knowledge but also your valuable time. Thank you, Ambade sir.
Thank you, sir. Namaste.
Okay, tomorrow's session will start at 12 o'clock. You know, sir, at 12 o'clock or 11 o'clock? Hello? Hello?
Yes, sir.
Yes, sir.
What is the time of tomorrow's session, sir?
12.
12.
12 o'clock, na?
12.
Tomorrow we have only one session. So I request and also inform all the participants to join at the on 12 o'clock on tomorrow. Thank you everyone for joining us for today's sessions. Thank you so much. Have a good day. Jai Hind, Jai Chhattisgarh.
कट गया था मैं